This not there for syllabus. Still, some people are asking. So there are. I'll just the derivation is not there, or so it's not in syllabus. So still better you remember. Parallel resonance circuit. So I can. So what is the resonance frequency of this? Omega naught equal to 1 by LC R by L whole square. Next, we maybe the inductor is ideal. See, inductor is not. What is this R? Not a wanted one. It's unwanted. The internal resistance of the inductor only can be R. Got this? So now it should be. It can happen that one. Inductor is ideal, but what will happen? The capacitor will not be ideal. Huh? In this case, the resonant frequency will be if R is very high, it become negligible. It'll become like a 1 by LC. If R is very low, so then what will happen to them? 1 by LC. And there's a parallel resonance circuit. Sir. There's a 1, 2, and we have series resonance circuit. Let me put that also here, so that will be easy for you. Tell me like, what is this R? It will be the resistance of the coil itself. Tell me like what type of coil you should prefer. Okay, now here comes the word choke. Tell me, to get the quality factor very high, what is the formula? Omega naught L by R. No? For very high quality factor, what should be the value of R? R should be very small. I'll make it smaller so that you'll understand what is the meaning of it. Tell me like, for resonance, and what is the resonance frequency? It just depends on. They may not ask as a question, but they may ask you general passage in advance. Possibility is there. Now you see you have all the information. I think I'll write smaller, so this will be much easier. Yeah, I think you are able to compare things very easily. Let's come for this. Quality factor. Quality factor should be as high as possible. So therefore, what type of inductor I should pick up? I should pick up inductor where L should be very large and R should be very small. Means I should pick up an inductor. So for a choke, the inductor is called as a choke. That one. So what is the like a inductor of high inductance, low internal resistance is called as a choke here. Inductor of high inductance and low resistance is called as choke. So this word is very important. A choke is connected means immediately what should flash for you? High inductance, low resistance. That's what happened here. So therefore in series resonance circuit, so shall I place inductor or shall I place a choke? I should connect a choke. Inductor means it can have high internal resistance also, but choke what happen will have low resistance. I think very troublesome. In some of the books open, they like in series resonance, a choke is preferred in series with capacitor than an inductor. Correct statement. A student should not bargain with the teacher. No, sir, inductor, choke, both are same. So whenever you design series resonance circuit, so you are going to see that high quality factor should be there. The sharpness of resonance should be as high as possible. So for that to happen, L should be very high inductance and internal resistance of the circuit should be very less. Who will offer that internal resistance? The maximum is offered by the coil itself, the inductor itself. So therefore, a inductor with high inductance, self-inductance and low internal resistance is called as a choke. So got the idea now? Now come for this. So what is this small r? The small r is nothing but internal resistance of the coil. Now come for this. What is the small r? Resistance of the dielectric slab between the capacitor. So here this r is having lot of meaning here. Resistance of dielectric slab between the plates of capacitor. And what is the smaller here? Internal resistance of a coil. And these derivations again we can derive. For this, what should happen here? No, parallel resonance circuit. We have to take help of current, not the voltage here. So how the overall response of the circuit will be here? If I plot the current IRMS, this is a resonant frequency. The current will be minimum at resonance. The current will be minimum and the impedance will be maximum. So I think there's a difference between series resonance and parallel resonance. Series resonance at resonance current will be maximum. In parallel resonance at resonance it will be current will be minimum. Then this is called like a rejector circuit. If I want to reject a signals, I'll go for it. If I want to select a desired signal, I want to reject that particular signal. I'll make the current due to that signal minimum by using parallel resonance circuit. So this is to reject a specific signal, parallel resonant. To select a specific signal, we'll take series resonant. So all these are what we use in communications here. Parallel resonance not there for syllabus, but still they can ask you as a general passage. So what is this R? R is rather than saying resistance of circuit here, no? Of course, resistance of connecting wires will come. The resistance of connecting wires will come. That will be negligible compared to this R. This will be R here. What happen will be very large here, no? Not small. So here smaller, very large will get neglected. We'll end up with this equation. Smaller here will be very small. Then you neglect this, will end up this one. This about in parallel resonance circuit. So in series resonance circuit, this will be the condition. Compared to resistance of the connecting wires, the resistance of the coil will be more in series resonance. So like that, what happen? The inductor cannot be ideal. It will have some resistance. Capacitor cannot be ideal. The dielectric slab will have resistance, and how it will going to affect the resonance frequencies here. So when designing these resonance circuits, I should take care what type of circuit I'm designing. Okay, the word choke, why it will come into picture? Because of this condition. So good theoretical questions can be asked here. Once again, what is the quality factor? It's a measure of sharpness of resonance or how good the circuit is selectively. So various definitions we have brought it. All that one. So next again, like in terms of R, we have started, this is from graph. Quality factor is equal to, this is from graph. From graph, we calculate using this formula. Graphically, we'll calculate this. From circuit parameters, this particular formula. Do remember, this will be. Then, in terms of energy, this is a formula. So different ways of expressing and how that resonant frequency, cutoff frequency, they are related by using this equation. Okay, I'll wind up. Tomorrow we'll discuss some numericals related to this also. Okay, thank you all of you. Okay, thank you all of you. Take care, bye, see you.
Sir,
Yeah.
about that